This is Advent of Code 2020, day 22. The puzzle is called Crab Combat, and this is part 1. In this first part, we've got a small deck of space cards, and we are on a raft headed towards somewhere, I guess the next part of our destination, and a small crab has joined us on this trip across the ocean, and in order to pass the time, we're going to play a game called Combat with this crab. And it sounds, from the description below, a lot like a card game that I'm familiar with called War, where each player plays a card from the top of their deck. The card that is the highest wins the combat or the war, and that player takes both of those cards and puts them on the bottom of their deck, and then play continues. Now, in the version of this card game that I'm familiar with, you will shuffle the new deck that's forming in order to add some sort of variety and randomness into the game. But in the case of this game, there's a very deterministic order in which the cards will be placed on the bottom of the deck. The higher card and the bottom card will be placed in that order on the bottom of your deck if you win. And in that way, we are able to simulate who will ultimately win given 2 starting hands of cards. So here we have player 1 with 9, 2, 6, 3, 1 in that order, player 2 with 5, 8, 4, 7, 10 in that order. And if you let it play out, you'll see that eventually after, 29 rounds, player 2 wins. They end up with all the cards, probably because they started with the only highest card, which is 10. And so for us, for this problem, what we want to do is not only simulate who the winner is going to be, but once there is a winner, we take the deck that they end up with at the end of the game, and we do this sort of scoring algorithm with the cards, where the last card in the deck gets multiplied, whatever its value is, gets multiplied by 1, and then the second to last gets its value multiplied by 2, so on and so forth. All of those get summed up. So in this case, there were 10 cards in total, and the player 2's top card was 3, so that gets multiplied by 10. And the result is 306. So we will work on a solution using this input right here, which is not too many cards. So we'll copy all of that, and we'll jump over the terminal here. I've already sketched out a class called Stack of Cards that we'll use. Before I walk through that, let's just open up input.txt and paste in the starting hands for players 1 and 2. We'll save that and jump back here. So the way Stack of Cards works is it's a class that we're going to use to represent each player's hand. We'll initialize it with those starting sets of cards like we saw in the input file. And from there we can draw the top card where we shift the top value from the array, and then cards gets mutated by that shift operation so that it then becomes only the remaining rest of the cards. If a player wins a hand, then they get to take those cards and stick them on the bottom of their deck, and so that's what add to deck does. It'll concat them to the bottom. And then we have this empty check in case we ever want to see if either the player's hands is empty, and then an adder reader so that we can ultimately grab the set of cards from a hand and do some math with it. So for starters, we'll need to read in the file. And so we'll do that like this. And we'll need to split the file apart into unparsed player 1, unparsed player 2, and we'll do that by doing a split on a double new line. And just to show that, you can see this right here is a double new line between player 1's cards and player 2. So that's how that's going to work. And from there, we can parse out the cards from each of these and initialize each of the hands. So to do that, we'll take unparsed, set no paste, unparsed player 1, and we will split that on new lines. And once we've done that, we can I guess ignore the first thing and then take the player 1 cards like that. So we'll do just a destructuring, and then we'll do the same sort of thing with player 2. Because if you remember from this file, the very first thing is going to be this line that says the player's name. We don't care about that, which is where what this will be. And then the rest of the things that are split on new lines will be the player cards. Yeah, I think we can initialize the hands, but in order to simplify how we work with the hands, I'm going to convert all of these stringed integers to just integers. So we'll say hand 1 gets stack of cards dot new, player 1 cards dot map, and we'll just 2i all of those. So now all those cards will be, so we'll be initializing this hand using an array of integers rather than an array of strings. And we'll do the same thing here, swapping out 1 for 2. And now we have both of our hands. And from here we can play the game. So to do that, I guess we'll say while hand 1 dot not empty and hand 2 is not empty. We'll just loop because we want to just keep playing the game until eventually one of those hands empties out. So we'll say, I guess, hand 1 dot draw. We'll do hand 2 dot draw, and we'll want to compare those. And once we compare them, whichever one is higher, we'll take both of those cards. Just trying to think if there's a clever way to do this, but I think we may just end up writing out several lines to handle this logic. So just player 1, player 2, if P1 is greater than P2, else, and hopefully we don't have any ties. Maybe we'll check to see if there's any ties. If P2 is greater than P1, P1, else raise standard error, we have a tie between P1 and P2. So we'll just raise that to let ourselves know. Don't expect we'll hit that though. So in this case, player 1 wins. So hand 1 dot add to deck gets P1, P2. Otherwise, if player 2 wins, then hand 2 gets P2, P1. Okay. And so this will continue until one of the hands empties out. Would be interesting to keep a count of turns. That's not asked for in the problem, but I'm sort of interested. And so at the end here, we'll put number of turns like that. And then we'll have to do some math. So I'll have to figure out which of these hands won. So if I guess we don't really care which one won, because either way it's just going to be, one's going to be an empty array, the other one's going to be an array full of cards. So we can, I guess, join them. Let me see. I say that, I think plus plus, is that a Ruby thing? Or am I getting that from another language? Whoops. I guess I can say and, no. Right. Okay. So maybe I'll do that. It's a little bit hacky, but it'll do the job. So we'll say final hand gets hand1.cards or hand2.cards using our adder reader there. And from this final hand, we'll want to say, I guess, final hand reverse dot each with index do, and then we'll get the card and the index, and we'll sum that up. I guess. Each with index dot map. I can do that, in which case the final thing would be summed. So I'll say card times index. And I think we'll say an index, starting index of 1 rather than 0. Dot map, sum it up, and result result, something like that. So will that work? Unparsed. Use normal case for variable numbers. Oh, I see, it doesn't like that. Okay. This doesn't really matter, but I'll do it anyway. Okay. So let's run this and see what we get. Number of turns, 0. Oh, whoops. Plus equal 1. I guess you can't do plus plus in Ruby. 825 turns. We get this 31,000 and some. Let's see if that will get us a gold star. And it does. All right. Well, that was it for part 1. We were able to use a nice little class to handle some of the conceptual pieces of the solution, and then from there it was just a matter of parsing the input and doing a bit of looping. Yeah, thanks for watching.